What is going on, guys? Modded Warfare here. Welcome back to another episode of the new PS4 jailbreak tutorial series. So in this episode, I'm going to be showing you guys how to use the ESP32S2 chip to auto jailbreak the PS4 without requiring a USB drive, constantly having to plug in the USB drive and unplug it whenever you want to jailbreak your PS4. This will do that for you. You just have the chip connected to your PS4 all the time, and it will emulate the USB with a hacked image on it and disconnect it once the jailbreak has loaded. So this can also act as a completely offline solution, or it can be used online as well, just like the Raspberry Pi. So if you wanted to set it up just for offline use, then you can. Or if you want to set it up for online use, you can set that up as well. I'll show both here in the video. It's pre-configured for offline use by default. So I've already covered this before using a Raspberry Pi. You can do this with a Raspberry Pi 02W, Raspberry Pi 0W, and Raspberry Pi 4B. So I've already covered that in a previous video. I'll link it in the cards in the top right hand corner and down in the video description. But there was a lot of comments under that video of people suggesting that it was hard to get a Raspberry Pi, one of those Raspberry Pi devices, for this method, mainly because they were either out of stock or they were at inflated prices. So they also require a micro SD card as well, so you have to factor that into the cost with the Raspberry Pi method. Whereas a ESP32S2 seems to be a more readily available chip right now. It's also cheaper and it does not require a micro SD card. So there's a few advantages to using this chip instead of the Raspberry Pi method. And, you know, there are some kind of pros and cons between the two versions, but we'll get into that at the end of the video. We'll compare them at the end. So the first thing you're going to need to do is grab yourself an ESP32S2. Not all of them work. It's only certain ones. I know the Tiny S2 works because that's the one I have, and the Feather S2 works as well. I believe Neo Feather S2 should be the same. So these chips here should work, and I'll have a link to where you can buy them in the description. You can get them from Amazon. The Tiny S2 I think is the cheapest one at about £20. So, you know, just go ahead and buy one and connect it up to your computer using a USB-C to USB-A cable. You can always just use your phone charger if you don't have a spare USB-C to USB-A cable. So the next thing we need is a host that we can flash onto the chip so we can run the jailbreak from it. And to do that, we're going to use Caro's host right here. There are other hosts available. This is just the one that I found on Twitter. So, you know, obviously other, hosters will have their own versions that you can use. So use whichever one you prefer. I'm going to use Caro's here. So I'm going to click the mega link. And that's going to take me right here. If there's a new version by the time this video goes out, I'll, have it linked below. So there's kind of two different versions. There's the PS4 Trainer with Gold Hen Web RTE, PS4 Debug, and Orbis Toolbox. Or there is the main sort of version that has all the regular payloads attached as well. So depending on which one you want, just select it. If you want the Trainer, then go for the one that has the Trainer. If you're not bothered about the Trainer, then just go for the other one. I'll go for the one without the Trainer just now. So we'll select that option. And we'll download the ESP32S2.bin file for auto emulates USB. So just double click it and it will download that to your computer. So now we need a program to flash it onto the chip. So to do that, we're going to use Node MCU Flasher version 5. I'll have the latest release link down in the video description. So just click the exe and download it to your computer. Once you've got it, we can then open up Node MCU Flasher. And we're going to browse for that bin file that we downloaded for Caro's host. So ESP32S2 auto emulates USB.bin. So we're going to browse for it and add it in right there. So next we need to be able to detect the ESP32S2 chip. So if we go into Device Manager on our computer. Now what you'll notice is that it's not showing up for me. This unknown device is not the ESP32. This is just another, device on my computer that I don't have a driver for. So that's not related. So I don't actually have the chip showing up. Now, you may run into a different behavior depending on what's pre-programmed onto your chip. So if you have something different pre-programmed onto the chip, it may be detected automatically when you plug it in. But in my case, it is not showing up here. It should show up in the COM ports, but it's not. And in order to be able to flash it, I need to switch the chip into download mode. Now you can switch the chip into download mode by holding down the boot button and then clicking the reset button once and then letting go of the boot button. And then when you do that, you can see that we now have stuff showing up here. We can see there's another unknown device that's popped up. And there is another COM port that's shown up as well, USB serial device on COM port 5. So it may not say unknown device, it might say ESP32S2, which is fine. So that's how we know we're in download mode or flashing mode, so that we can actually flash the bin file to the chip. So it's now showing up there on COM port 5. So all I'm going to do is click reload and then select COM port 5. Now you might be able to flash your chip without switching it into download mode, depending on what board you have and what's pre-programmed onto it. But in my case, I have to switch it to download mode in order to program it. So from there, we can then select the baud rate on 115200 and the flash mode on DIO. And erase flash, yes, wipe all data. And then from there, we're going to flash node MCU. So it starts off by erasing the flash, and then once it's done erasing the flash, it then starts writing our bin file to it. Okay, so that's it, reached 100%, just waiting for it to complete. There we go, firmware successfully flashed. It says to unplug or reset the device to switch it back to its normal boot mode. So I'm just going to go ahead and hit the reset switch on the chip, so the reset button. I'm going to hit that button once, and then if I go back to device manager, you can see it's no longer showing up, so it has been switched back into the normal mode. So we can now close out of Node MCU Flasher, and as you can see, we should have the Wi-Fi network showing up here. There it is right there, Caro, so it is working. I'm just going to stay connected to my main home network right now. So all we have to do now that we've confirmed it's working is unplug it and plug it into our PS4. Okay, so switching on to the PS4, all we're going to do is connect to that Wi-Fi network. So go to your settings, go to network, set up an internet connection using Wi-Fi, and then we'll just select an easy setup, and we'll select the Caro host right there. And if it prompts you to enter a password, then just enter 12345678 as the password, and that should work. I believe I've already entered the password before, so the PS4 saved it. But you will be prompted for a password, so just enter 12345678, and then you'll be good. It should connect. And as you can see, internet settings have been updated. If we view connection status and wait for it to obtain an IP address, you can see we now have IP 10.1.1.2, and the default gateway is 10.1.1.1, and the DNS as well. So from there, you can just go to the user guide to run the jailbreak. If we go here and wait a few seconds, it should do the auto USB emulation. So it takes a few seconds here on a white screen before it actually pops up, and then it should only take a couple of seconds for the USB message to appear. So there we go, USB storage devices file system is unsupported. And there we go, it's done. Successfully jailbroke the PS4. It hasn't run a payload yet. It doesn't automatically run Gold Hen for you. So you just have to go to Gold Hen and select it, and then wait a few more seconds for it to load the actual payload. And there it is, Gold Hen version 2.1 loaded. See how easy that was. I didn't have to plug in a USB drive, and it kind of loads faster than, you know, even the Raspberry Pi method takes quite a while before the USB message appears, whereas this, you know, the USB message appears quite quickly. So there we go. We loaded that completely automatically, didn't have to plug in a USB drive into my PS4 to jailbreak the system. So if you are having any trouble accessing the site from the user guide, you can clear your website data by going into the web browser, hitting options, going to settings, and clearing your website data. And that should fix it if you're having any errors. And if that's still not working, you can of course access it through the web browser app itself by just going to caro218.ir, which should redirect you to the site right there. Or you can go to 10.1.1.1, the actual IP address, which will also take you here as well. Okay, so that's basically how you get things set up for offline use, which is the way it's set up by default. You just connect to its own isolated Wi-Fi network, and then you'll be able to access it through the user guide or via the IP address. And it's a completely isolated network, so you won't accidentally connect to the internet. But what if you want to connect to the internet to be able to use things like the patch installer and the homebrew store, or just be able to access the actual web browser and go on whatever websites you want, as well as still having access to that USB emulation on the ESP chip? So in order to get it working online, there's quite a bit more setup that is involved. But if we switch over to the computer, so what we're going to want to do is connect to the ESP network on your computer. So connect to the Caro network here on our computer, enter the password 12345678, and then connect to it. Once you're connected, we can then go onto our internet browser and then go to caro218.ir/admin.html. So /admin.html at the end, or you can do 10.1.1.1 /admin.html, and that should take you to the same place. And this will take you to the main configuration page for the ESP32. So there's a few options in here. There's a file manager that allows you to remove payloads, download the payloads to your computer. And there's also a file uploader, which allows you to upload payloads to the chip. Now, the Caro host, the current version of the Caro host that I'm using, doesn't dynamically add buttons for each payload that is in the list, which basically means if you add an additional payload in here, it won't show up on the host. You can replace payloads that are already in here, but they have to be named the same. And you have to kind of, if you download the payload as a bin file, you have to convert it to a JavaScript file, which is like a JavaScript array of the payload that has some code to load it. And you also then need to compress it into a gzip file as well. And then you can upload it using the file uploader. But because Caro's host doesn't currently support dynamically adding buttons for each new payload that you add, then it's not really, I'm not going to bother covering it because it doesn't really work properly in this host. But again, if it gets updated, if a new host from Caro comes out or another host that does dynamically add the buttons, then, I'll link it down in the video description. So there's also a firmware updater, so you can update the firmware for the chip as well. So the next thing we have is the config editor. And in here, you have the option to change the auto USB wait time. It's set to 10 seconds right now, so 10,000 milliseconds. You can change this to whatever you want. So if you are running into any issues when trying to load the exploit with the USB emulation on the chip, and you're running into issues where you're getting the failed to trigger exploit message, which keeps coming up constantly all the time. If you're constantly running into that error, then sure, you probably should change this to something else. Maybe make the wait time a bit longer. Maybe change it to 11 or 12 seconds, so 11,000 or 12,000. Or maybe shorten it a little bit to maybe 7 seconds, so 7,000. And, maybe you'll get some more success with that. But obviously, if it's working fine for you as is, I wouldn't bother changing this number. I'm just going to leave it on default. You also don't want to touch anything in the access point settings either, because we're not really going to be messing with that. There's no reason to. What we're going to be doing is changing the Wi-Fi connection settings. So there is one thing in the access point settings you can change, which is you can turn it off if you're not going to be using it as an access point, and instead you're going to be connecting it to your home network, which is what we do in order to be able to access this online. We want to connect the chip to our home network so that it will appear as a device on our home network that we can then go to still access the web page and access the USB emulation, but will also be connected to our home network as well so that we can still access the internet at the same time. So in order to do this, what we need to do is change the Wi-Fi SSID to the SSID of your home network. In my case, it is this Fritzbox here, 7530SB. So I'm just going to enter that right in here. I've already got it saved. So I'm going to enter the SSID of my home network, and then obviously enter the password of your home network as well. And then you can also change the host name as well. So, if I call it ESPhost.ir, so I know what that address is. And then I'm going to go ahead and select the option to connect to the Wi-Fi network. And that's all you really need to do to set up the Wi-Fi connection. If we click Save Config, it will reboot the ESP chip. And then once that's done, it should then reconnect to our home network. And then all we have to do is obviously reconnect to our home network here on our Wi-Fi settings. Okay, so now that we've reconnected to our home network, we need to get the IP address of the ESP32S2 chip, which is now connected to our home network. So we need to get that IP address. Now, there doesn't appear to be a very simple way of doing this. It would be nice if we could log back into the ESP chip and it would just tell us what its IP address is. But there's not apparently much of a way of doing that right now. I mean, hopefully some other host might come along and just add the IP address into the host so that we know, just like the Raspberry Pi host did. But right now, the only way seems to be to actually log into your router and find it. So what I'm going to do is open up a command prompt window, type in ipconfig, and then grab the default gateway address as I'm connected to my home network. And then I can just paste that default gateway address into my web browser. That will take me to the login page for my router, and I can then log straight into it. Now, of course, your router is going to be very different to mine when you log in. So you just have to find the location in your router page that shows you all of the devices that are connected to your Wi-Fi network. So this shows me right here. I can see it. ESP host is right there. If I click it, it takes me to it, and you can see the IP address 192.168.1.42. So I now know the IP address of the ESP chip on my Wi-Fi network. Another thing is that if your router has the option to make the IP address static, then definitely choose that option. So I can go to edit on the ESP chip, and then from here I will have an option to always assign this network device the same IPv4 address. So by selecting that option, I'll never have to look up the IP address again. It will always stay the same. So if you have that option in your router, definitely use that option. So anyway, now that we've done that, we can then switch back over to our PS4 and just connect our PS4 to the home network as we normally would. So if we select Wi-Fi networks, we'll do a custom setup, and then we'll select our Wi-Fi network, and then we'll do an automatic IP address. Do not specify DHCP. We'll do a manual DNS, but we'll just use the Al-Azif DNS addresses to block connections to Sony servers, and then we should be good. So now we're reconnected back to our home network. So if I go onto the internet browser and try and go to Google, for example, you can see it loads up. So we do have internet connectivity, but I can also go to 192.168.1.42 right here, and that takes me to the auto jailbreak that's hosted on the ESP chip. So I'm still able to use this auto jailbreak feature. As you can see, a USB device system is not supported. I got an out of memory error here, so let's see what happens this time. Oh, there we go. We still loaded up. Let's try Gold Hen version 2.1. And there we go, loaded up successfully. So it just did that, no problem, as it did before, but this time we're connected to our home network, so we have access to the internet. We can use programs that have online connectivity, like the patch installer to download patches, Apollo Save Tool to download modded saves, or the Homebrew Store to download homebrew apps. We can still do that while still having access to the ESP chip to do our auto jailbreak for us. So that's the advantage there of using that chip. Now, compared to the Raspberry Pi, it's pretty similar. The Raspberry Pi is a bit better the way it's set up right now because, again, you can add payloads and it'll dynamically add the button into the host for whatever payload you uploaded. It has more space because you're using an SD card, so you can upload more payloads. You don't have to compress them like you do with the ESP chip. So it has a few advantages there. Plus, you can also mount the SD card as a USB on the PS4 so that you can install package files via the package installer from the SD card. And it has an FTP server, so you can upload payloads and stuff to it through FTP as well. So yeah, it's a bit more feature rich with the Raspberry Pi method, but with the ESP32S2, it's cheaper, it doesn't require an SD card, and it's also more readily available. So highly recommended. I would recommend either the Tiny S2 or the Feather S2. Just remember that the Feather S2 has a larger flash, so you could fit more payloads on it once we get a host that actually dynamically adds buttons for the payloads that you have on your ESP chip. Once that happens, I'm sure there might be a host that already does that that I haven't seen. If there is, then I'll link one in the description, or maybe Caro will update his host to include that feature. And once that happens, then the Feather S2 would be the better option with the more storage space. But again, the Tiny S2 is another good option. You can just compress the payloads or delete any payloads that you're not going to use, and that'll free up more space to add more payloads. So yeah, it's a great option. Again, cheaper, doesn't require an SD card, more readily available chip. So definitely check it out if you're interested. So hope you guys enjoyed the video or found the information useful. If you did, please leave a like and subscribe, and I'll hopefully see you guys in the next one.